All right. Good morning, everyone. I'm Dr. Samuel Lawrence. I am the Science Mission Directorate's Artemis Mission Planning Lead. In that role, I serve as the technical lead for the Artemis Geospatial Data Working Group, which is part of the Exploration Systems Mission Directorate. Exploration Systems Development Mission Directorate. I'm here today to give a brief overview of the Artemis 4 landing site process. And before I get started, I just want to stop and everyone should just take a quiet moment of reflection to appreciate the wondrous nature of the fact that we are now, this is a big milestone in terms of planning 2 American surface lunar missions for the first time in over 6 decades. We are now simultaneously working to execute 2 missions, and that is no small achievement and reflects a lot about the perspicacity and legerdemain of this community and our persistence in advocating for a strong American presence on the surface of the moon and an expansive exploration program. So like any presentation, especially ones given by NASA in the context of Artemis, I am here today on behalf of a much larger team. The Cross Artemis Site Selection Analysis team is working diligently every day to coordinate a lot of the activities associated with the site selection process. It is a 5-person board. I think we've shown this slide at several previous meetings before. It consists of Dr. Jake Bleacher, the ESDMD Chief Exploration Scientist, Tamara George, the Surface Mission Planning Lead from the ESDMD as part of the Moon to Mars office, Brad Bailey, the Assistant Deputy DAX for Exploration and SMD, our good friend Sarah Noble, the Artemis Lunar Science Lead, and new for this iteration of CASSA, Kristen John has replaced Jonathan Bowie as the representative from Space Technology Mission Directorate. So welcome, Kristen. We're very delighted to have you here. The CASSA is supported by a number of technical assessment teams across the entire agency. There are literally hundreds of people working on this. I do want to highlight, you will note over there, the Science Objectives Assessment Team is led by myself and our good friend, Dr. Noah Petro, that is involved with helping to pin down science objectives that can be accomplished by Artemis surface missions. And the Lunar Data Assessments Team, the Artemis Geospatial Data Team, also led by myself and Dr. Petro, serves in a strong support role for CASSA, working to provide the detailed technical analyses to achieve these missions. We also involve project teams, other teams across the agency. There are literally hundreds of people working on this. All Artemis site selections get approved at the headquarters level. And we really do try to integrate a broad and diverse community of stakeholders as we plan these missions and try to select landing sites to achieve these national goals. Okay, so you've seen versions of this particular slide before in the context of the Artemis 3 mission. We've shown versions of this several times. Basically, we follow a detailed iterative process for Artemis lunar landing site selections. The Artemis 4 mission is solidly here in step 1. We're working to determine agency objectives that drive site selection. These includes utilization, which includes science activities on the surface, as well as logistics, infrastructural placement, other activities on the surface. We're here. We're working to define it. As Barbara hinted at, we have a direction that we're taking with the Artemis 4 surface mission increment, and that's kind of where we're at with step 1. Step 2 is then after we decide what the agency objectives are for the mission, we consider the capabilities of each individual program element to meet the agency strategy. Step 3 is we determine potential acceptable terrain sites in areas that meet these agency objectives and begin to assess their vehicle capabilities in conjunction with our commercial partners. We are doing this together with private industry as part of a public-private partnership. And so we don't, we have to work very closely with our industrial partners. Step 4 is where we do in-depth lunar surface morphometric assessments and really work hard to understand the overall architectural compatibility of the analyses. And then finally, in step 5, we apply the weighted figures of merit for various sites to maximize and balance drivers with mission availability. So it's a very detailed process. It's very iterative. There's a lot of steps here. A lot of people work really hard on this, but we have a process and it's set up and it's actually working fairly well. So we do, as evidenced by the fact I'm the one giving this talk, science has a relatively large role to play in this activity. And especially for Artemis 4, where we're sort of getting in earlier with the site selection activity in an effort to try to drive it towards a bit more of a science-driven process. So let me talk a little bit more about mission availability. So mission availability is a challenge. It's a multidimensional challenge. It is kind of hard to wrap one's head around sometimes, but it is a concept that I can describe thusly as the opportunity frequency at which the end-to-end mission can be viably conducted. So everything starting from integration to launch, execution, landing, post-flight operational assessments. That's the whole integrated perspective of how the mission operates. This factors in things like the actual launch days, windows, periods. We may accept some constraints more than others in order to achieve or optimize for different objectives. And on the right-hand side, you'll see all the different things that factor into this. The performance of the launch vehicles on the ground and during the launch phase, to transit performance, to the thermal environment in cislunar space, the communications environment in cislunar space, the rendezvous planning, the communications, the illumination conditions during the landing phase, the performance of the lander, the terrain of the moon upon which the lander is landing, and the science and exploration goals of the mission itself. These all factor in to mission availability. There is a distinct set of additional constraints that must be incorporated when planning a human exploration compared to science missions. So this is a very iterative process. It starts now with the design of the architecture and the development of the flight articles that we're developing to implement the architecture. It requires a lot of careful coordination and collegiality and communication amongst all the various stakeholders. It is a lot harder than planning a SMD style robotic surface mission. But the benefits that we will get will be immense, and it's worth it to achieve those great aims. So, move on here. So a frequently encountered question is why do we have to carry so many landing sites? And the reason why is that we really do need flexibility. There are multiple variables driving the need for flexibility in the site selection process at this time. There are constraints that could drive other regions for mission availability needs. The site selection will shift when the availability and or capabilities of various elements change. So this could consider what other assets are available and their placement during the appropriate timeframes for the mission. The best place to land, especially in the Artemis South Polar Exploration Zone, is often also a place that is great for stationary multi-year elements and or other landed missions. So this drives extra steps in the process to balance various strategic national posture needs. Each of these activity will impact the final site selection for the Artemis 4 mission. You see on the right, this is a figure produced in the context of the Artemis 3 mission, but still relevant for Artemis 4, various potential candidate landing regions that were originally assessed for the Artemis 3 mission and are now also being assessed for their potential usefulness as part of the Artemis 4 mission. That isn't really what we want to talk about here today. We want to hear about the figures of merit and what might make a good landing site to achieve the geochronology aims of this particular mission. But I just bring it up here as an illustration of we really are thinking really hard about this, and assessment work is already underway. So with that, I will stop talking. As always, we are going together, and you can follow our progress on various internet social media platforms. Thanks very much.